what, which is 11.6.1. Let's see. 11.6.1. Yeah, show that there's a infinite number of solutions. Yeah, that's a little bit tricky. That might be more than one method to show it. But my way to show it just found out the explicit solution. So this is an equation, right? So when you write it like that, it's an equation. So we always talk about function of this form is that there's a essential singularity at c equals 0, right? We talk about that. Now, if the question asks you at c tends to 0, which means the magnitude also tends to 0, obviously, then you have a infinite number of solutions for this equation. And what I did is just try to solve it explicitly. So basically, you take the log of both sides. So 1 over c is log c0, c sub 0, which is log of magnitude of c sub 0 plus I, the phase angle. But then the angle can increase by any integer of 2 pi's, and you get the same complex number. So there's infinite many n times pi to n pi, right? And this integer. Okay. And now you know that you just inverse that is I mean 1 over z is that c is just 1 over whatever, right? And because n is there's infinite number of n, then this number is there's infinite number of this. It's the solution of c is there's an infinite number. Right? You just write it down explicitly and see that there are infinite many solutions, right? Because they are different after you get this. So you change at to n pi to the phrase z sub 0 is the same. The log, after you take the log, is different. And the inverse there is also different. So all these are different numbers for z. All these are different. Is that okay? So I just did it that way. Yeah, from past experience, some people like, I don't know, get this a power series or something like that, and say that the n many solutions infinitely series. I mean for past classes I saw answer that probably is okay. I thought that is not as straightforward as just write down the explicit solution. And I mean, one way to have a z sub 0 goes to infinity. I mean, for a fixed of 0, you have n also. N is also the imaginary part in the denominator is can go to any large number. So the real part. Let me write that explicitly. I just say sometimes. So the real part is log c, and then the imaginary part is pi plus 2n pi, right? Then the magnitude obviously is going to 0 because magnitude of 0 is 1 over square root of square from 2n pi square. That goes to 0. And goes to right. You can take as large n, I mean plus or minus value, and this is still extreme. I mean, unboundedly great. This factor, so that the magnitude of Z will be as small as you want. You just choose it. No, I mean, you can, if you like mathematics, you can use the delta epsilon method to show that for any given small value of Z, you can find a large enough M such that this value is smaller than that, the given, well, the given small value, right? Is it okay? Yeah. Once you write down the explicit form, you can see that would be possible. Is it okay?